Okay, this is the answer to example number 3, I think, second part. So, with these ones I'm not going to tell you the answer, I'll give you some advice on what to do. So, looking at this one here in the top left, that one, to find the total resistance, we need to, you can see that there's a parallel part, okay, so there's parallel is there and there, okay, and there's also a series part. Now when you look at these circuits, you want to look for what can you reduce down first. In other words, I can't use the parallel formula because it's not going to be 1 over 20 plus 1 over 20 plus 1 over 60, because the 60 and the 20 here are not in parallel, so they can't be used in the parallel formula. And I can't just do 1 over 20 plus 1 over 20 because we're ignoring this one here, which is also in parallel. So what you need to do first is do the series part. So we'll combine these in series to make essentially a imaginary resistor, and you can actually see the value would be something around 80 ohms. Okay, and then you've now just got two resistors in parallel, so you just combine those two. Also, to help you for, let's say, the currents, so that current and that current, there's 24 volts on this side, so everything attached to this side, all these wires, have a potential of 24 volts, or 24 joules for every coulomb. However, on this side, there's 0, so everything along here is 0. So what's the potential difference across that 20 ohm resistor? Well, it must be 24. Okay. The potential across both of these resistors here must be 24. Okay, so 24 divided by 80 should give you that resistance. Sorry, that current. Similar thing on this one here. You've got these two resistors in parallel with that one, so you do the same thing as that one. However, we then have one in series. So something to be aware of is that the 24 volts might be 24 volts here, but you might then end up with something like 8 volts on this side, so all of that must be 8 volts, and then you'll have 0 volts there. So it's 24 here, and then you're going to drop a certain voltage across there and across there, okay, and you can actually then see what the voltage is here. So to find the total current, total resistance, you first combine those two in series, then you'll combine those two in parallel, and then you'll combine that and that in series. And I'll leave the last one for you.